Okay, let's discuss about how to solve a linear system of equations with three variables by using linear combinations, which is elimination and substitution. Okay, for this example, I have already given you three equations here. One, two, three, and each equation consists of three variables, x, y, and z. So solving this linear system means that we need to find the value of x, y, and z that satisfies all of these equations, these all three equations. Okay. So before we begin with the elimination, let's label it first. So let's label the first one with 1, the second one by 2, and then the third one by 3. So let's label the first equation, second equation, and the third equation. Okay, and then the first step, choose two pairs from three given equations. So since we are given three different equations, we need to choose at least two pairs from the given three equations. For this example, I will choose the first pair is the first and the second, and then the first and the third. So I have already choose two pairs. So of course you can choose the second and the third as your pair, but again, we just need to choose at least two pairs. Okay, for my example, I choose these two pairs. So next step, the second step, I have to do elimination for each pair. Okay, but keep in mind that I have to eliminate the same variable for both pairs. So let's just continue. Since I choose the first pair is the first one and the second equation, so this one and this one, let's just rewrite the equations here, the first one and the second one. Okay, and I need to choose which variable that I need to eliminate. So who's the lucky one? X, Y, or Z? Okay, let me see. I will choose X. Okay, let's eliminate X. Okay, since I want to eliminate X, I have to make the coefficient of the X the same. So I will multiply the first one by 2, and I will multiply the second one by 5. And this is the result of the multiplication of each equation. Okay, since I have already had equal values of the x, but this one is positive, this one is negative. Therefore, I will do addition. Okay, when I add these two, I will have this as the result, another equation, but I have only two variables. I have already eliminated x. So let's label this one as the fourth equation. Okay, this is the fourth, since we have already had 1, 2, 3. So this is just the fourth. Now, since we have already finished with the first pair, let's go to the second pair. Okay, since I want to eliminate the first and the third equation, let's just rewrite the first and the third equation here. But keep in mind, since I have already decided to eliminate x for the first pair, therefore I have to eliminate also x for the second pair. Okay, so it's not optional now. We have to choose eliminating x. So to make the coefficient of the x the same, I need to multiply the first one by 3 and the second equations of this pair by 5. Therefore, I will have this as the result of the multiplication. Okay, so I have already had equal value of the x, of coefficient of the x. Therefore, I will do subtraction. Since the coefficient had the same sign, so I will do subtraction. The objective is clear, eliminating x. So this is the result, and we have already had another new equation, consists of two variables only, y and z, and let's label it as the fifth. Okay, so we have already had two equations, different equation, and only two variables. So the next step is do elimination between equation 4 and 5. Since we have already, so since it is two equations with two variables, so we can use the two variables elimination. So let's just do rewrite the fourth and the fifth. Okay, rewrite here. And I need to choose what variables that I need to eliminate next. So let's just choose between y and z. Well, I don't like this big number, therefore I choose to eliminate z. Okay, I want to eliminate z as the second variable that I want to eliminate. Therefore, I need to make the coefficient of z the same. I will multiply it by 7, and I will multiply the second equation by 8, and then this is the result of the multiplication. Okay, and I have had the same coefficient of z for two equations, right? And since it is the same sign, I need to subtract, and this is the result. Okay, so let's just scroll this, and I will find the value of y equals 1, since I divide both sides by 100, negative 135. So I already found y, okay? But do not be satisfied, since we need to find the value of x, y, and z that satisfy all of the three equations. It means we need to go further to find z and the value of x. So what's next variable that we can find? So let's go to the fourth and the fifth equation. Since the fourth and the fifth equations consist of only two variables, so it is easier for us to find the value of the other variable. Do not directly use the first, the third, and the second. Okay, so let's choose the fourth step. Substitute y that we have already found to equation 4 or 5. Okay, to find, for this example, to find z. Since we have already found the value of y, so we can find the value of z. So for this one, I will choose fourth, the fourth equation, okay, not the fifth. So let's just choose the fourth equation. This is the fourth equation, and I will substitute y by the known value of y that I have already found, the y that satisfy all equations. So I will substitute y by 1, and with simple algebra, I will find this, and I will divide both sides by 8. I find the value of z. So y and z, I have already found the value that satisfy all the three equations. Next, I have to find the last one, x. How to find x? So we have to use one of these three. So now we can choose one of these three and substitute y and z that we have already found to find x. For this example, I will choose the second one. Let's just choose the second one. So I will rewrite. So yeah, this is the fourth step. Substitute y by 1 and z by negative 5, since we have already found the value of them. And we choose to equation 1, 2, or 3. You choose to find the value of the last variables, which this for this example we have it as the x. So now let's choose the second. I want to choose the second. Okay, it's free. It's free. You have to choose it by own, but I prefer the second one. So let's substitute the value of y and z that we have already known. So, and we do the simple algebra, and we find the value of x equals negative 1. So we have already found all the values of x, y, and z that satisfy all of these three equations. But don't forget, we need to go to the final step, the fifth step. Write the solution set, since this is the solution of these three equations. So since it is a coordinate of x, y, and z, in the braces, you put the one coordinate, okay, negative 1, 1, and negative 5. So we're done. This is the solutions of the three equations by using linear combination.